Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is Physics 5054 and today we are going to conduct the recording of lecture number 24. In the previous lecture, we discussed the concept of measurement of the densities of different objects. In this lecture, we will continue the exercise we started in the previous lecture. We did the multiple choice questions. Today we are turning our focus to the section B, which is all about the structured questions. The first question is saying in A part, there is a part of it in which one number subpart is there. So explain the following observation. Number one, the mass of a piece of rock measured by means of a beam balance is the same on the earth and on the moon. Remember that beam balance measures the mass and cannot measure the weight. So the mass, as we say, will remain constant everywhere if it is on the moon or on the earth. But because beam balance will have less weight, less pull on the pan of the beam balance, and on the earth it will have different force, weight, gravity on the pan of the beam balance. So the mass will be, because W is equal to mg and W is a force. So masses will remain the same, but beam balance will not measure that both are the same. Okay. Now the second part is saying the weight of the same piece of rock measured by means of a spring balance is different on the earth and on the moon. The mass will remain the same, but measurement is a different process. If you are measuring on the space, the mass, so mass will be the same, it will not be reduced, but the measurement process will give you different values. Now in the second part, they are saying that spring balance is doing what? A spring balance measures the force which might be a weight as well. So that is F is equal to MA, W is equal to mg. Remember that on earth, on earth, G is equal to 9.8 meter per second square. But on the moon, its value is different. So on moon, G is equal to 1.625 1.625 meter per second square. Different. So the weight will be different of the same rock. Mass will remain the same, but the uh, spring balance will give you different values. On the earth one value, and on the moon there will be another value. Okay, the B part of this question is saying that distinguish between mass and inertia. The very important part of this is how are they related. So first I am writing inertia. The tendency of a body to resist its state of motion or rest. While on the other hand, if we discuss mass, so the quantity of matter contained by a body. Now they are related directly to each other. What does it mean? Let me write a very important sentence, and I am writing that in red. Inertia is the direct measurement of mass. This sentence shows that it is directly related. What does it mean? It means more mass and there will be more inertia, and vice versa, and vice versa. Less mass and then there will be less inertia. So inertia and mass are directly related to, it is directly proportional. Inertia is directly proportional to the mass. More inertia means more mass. Less inertia means less mass. Okay, a student was traveling on a bus. This is very important question. A student was traveling on a bus and he standing in the middle portion of the bus. When the bus driver suddenly jammed on the brakes, a wooden box hit the student's legs. He claimed that the box came from the front portion of the bus. Is his claim true? Explain your answer. Ladies and gentlemen, his claim is not true. This is also the B part. I am writing no his claim is not true. His claim is not true. Explain your answer. When the bricks are suddenly applied, then the wooden box is was moving with the velocity of bus. Welcome from backward direction, because the box will move, and when the bus comes to rest. So his claim is not correct, because when the bus suddenly when the bus suddenly applies the brake, the wooden box was in the contact with the surface of the floor of the bus. So the bus is coming to rest, but the motion of the wooden box will continue. So it will move in forward direction. So the claim of the student is he was saying that the box came from front portion is not correct. And that is the answer of this. Now question number 2. We are turning our focus to question number 2. Question number 2 is saying the moon has a gravitational force 6 times that of the earth. If a person has a mass 60 kilogram on the earth, how much will be uh, he weigh on the moon? Is W is equal to mg, so W is equal to 60 into 1 over 6 of 9.8. क्योंकि it is given, because it is given in the because it is given in the question that it is 1 over 6 of the, so that will be this much Newton. So when we calculate it, it will come out to be 98 Newton. And that is the answer. Question number 3. And we are saying that a boy has made a model ship with the mass of 1.1 kilogram and a volume of 900 centimeter cube. Now let us write the data. Mass of the model ship of the model ship made by that boy is 1.1 into 900 kilogram per centimeter cube. Kilogram per centimeter cube, which is equal to 990 kilogram, 990 kilogram per centimeter cube. Now we have to convert it to meter. So when we are writing it in the meter, we have to divide it by 100. So it will come 9.9 kilogram per meter cube. The question is saying, will it float on the water? The density of water is, this is question number 3. Yes, it will float on water. Yes, it will float on the water because its density is less than the water. Its density is less than the water, which is 1000 kilogram per meter cube, and that is 9.9. Now question number 4. We are going to solve question number 4. The safe operates the M113 Ultra APC. This armored vehicle has a mass 1.1. So we are writing the data. Mass of vehicle is equal to 1.15 into 10 raised to the power 4 kilogram. 10 raised to the power 4 kilogram. When loaded, but yet is able to float. Uh, its mass is very big, yet it is able to float. What we can say about its volume? Density of water is 1000 kilogram per meter cube. So let us solve it. As volume is equal to, as density is equal to mass per unit volume, density of water is given as 1000, and this is 1.1 into 10 raised to the power 4 kilogram, and we have to talk about the volume. So we can write here volume is equal to 1.15 into 10 raised to the power 4, and then we can write 10 raised to the power 3, 1.15 into 10 raised to the power 4 minus 3, and that is equal to 1.15 into 10 volume, and that is equal to 11.15 kilogram meter cube. That will be equal to this much. So we can say that this volume will be less. If the mass is more, then volume will be less. If we are dividing that by more than, so then we will get a different answer. So volume in this case will be this much. Let me erase the whiteboard and do the next question. Now we are doing question number 5. And question number 5 is a bit exception from the chapter. We learned that how to find the volume of regular shape object, but in this case we will find the volume of irregular shape object. How to find? The question is saying describe how would you measure the density of an irregularly shaped solid by means of simple experiment in the laboratory. Now, this question is also very important. Take a graduated jar, pour some water in it and measure its volume, and that will be V1. Now gently drop the irregular shape object and note its volume V2 again. The volume of the object will be V is equal to V2 minus V1, and that will be in meter cube. So in this way you can find uh, the part number B is saying a measuring cylinder contains 100 centimeter cube of water. So we are writing the data for B part. That was the A part, and this is the B part. And in B part they given us the data as V1 is equal to 100 centimeter cube. 100 centimeter cube. This will also be in centimeter because graduated jar cannot measure it in meter. So it will also be in centimeter cube. Okay. V2 is given as 70 divided by 7.0 centimeter cube, which is equal to 10 centimeter cube. 10 centimeter cube, because the question is saying that object of mass 70 gram is lowered into the cylinder given that the density of the object is 7 gram per centimeter cube, and that is completely immersed. Calculate the new reading on the measuring cylinder. So new reading is equal to new reading is equal to 100, yani this one, plus this one which is 10, and that will be equal to 110 centimeter cube. Now we are turning our focus to the question number 6. Question number 6, and that is the final question. A simple question is there. They are asking something from you people. They given empty spaces. So a breakfast cereal packet carries the wording, this package is sold by weight, not volume. Some setting of the contents may have occurred. Some settling of the contents may have occurred during transport. If settling has occurred, what changes, if any, will have occurred to each of the following? The mass of the contents is unchanged. The mass of the contents unchanged. You have to write here because mass will remain if it is pressed or whatever done during the settling. The mass will not change. The weight of the content is also not changed. The weight of the content is unchanged because it is on the earth. Nobody has transferred it to the moon. So the weight and the mass will, the volume of the content, volume of the content, if it is pressed, the volume of the content decreases. Yes, if it is a powder and you press it, so the volume will be decreases, will decrease. The final is saying the density of the contents is increased. When you are pressing, the density of the content uh, increases because more atom in a less space, so it will increase. Ladies and gentlemen, that's it. Tomorrow we will start a very, very important because the students are always complaining that this chapter is very difficult. It is not that much difficult. It is easy, the turning effect of forces. So don't miss tomorrow's lecture. We will meet in the next video in the same channel tomorrow. So till that time, take care of yourself and your family member. Thank you very much. Allah Hafiz.